all should have this page here in front of us. And like I said, we're going to just talk about equations of circles today. It's going to really kind of just branch off of the last couple of units because we've been talking about circles in the last few weeks here. So we're just going to continue with that. But I want to go over what the equation of a circle looks like and how you would pull some information from the equation of the circle. Particularly, we're going to be looking today for how do you identify the center of the circle and how do you identify the radius. If you know those two things, you can either write the equation of the circle or you can pull that information from the equation and then potentially graph it if that's something that they want you to do. I'm going to go over with you guys how the equation of a circle got created and why it looks the way that it does, because it is a little bit different than any equation that you've maybe seen before. In the past, especially like last year in algebra, you probably spent a lot of time graphing linear things like lines, and those would be in that like y equals mx plus b form. You've probably heard that multiple times when you guys were in your algebra class. You maybe even talked a little bit about graphing a quadratic, which would be something with like an x squared. And there's other things that have like x to the third power, x to the fourth power. Those are all called different things. They all have a different equation to them. Circles are no different. Circles have their own equation as well, but circles equations have a little bit more to it, I would say, than like a linear equation does. When you have a circle, you need the center and you need the radius. The center is always going to be known as this point HK. So I have that up there at the top. Now the reason why they use HK instead of using x and y is because in our equation, there's going to be an x and a y in it that are always going to be in it that kind of represent points that could be on the circle. So we have to use different letters to represent the center. Otherwise, we have a whole bunch of x's and y's going around and it gets confusing. So we use HK to help us do our center point. And you can even see on my picture of my circle that's graphed here, this point here in the middle is that HK that I'm talking about. Okay, then it also says here, we also have another point, XY, that's graphed up here, and that's on the edge of the circle. Now really, that XY could be anywhere on the edge of the circle. It doesn't just have to be there. It could have been on any outside edge of the circle, okay? But when I think about connecting the center, HK, to this point, XY, what are we used to calling this segment on a circle? A radius. So normally the name we give this distance is a radius. And that's why they have in your picture a little r here. Okay, so the little r is representing that radius. Now in the past, when we had circles on a graph and we wanted to figure out what the radius was, all we really had to do is count squares. Like from the center, we would count squares either over to the left or to the right, or we would even go up or down, because we were able to easily count squares in those directions. Well, we can't really do that for this one for a couple of reasons. One, there are no squares provided to me on here. So I don't even know like how many squares would be from the top to the bottom of the circle or left and right. I also have like no numbers on this graph except for the origin here, which is 0, 0. But even my center and this point XY, there's no numbers there to help me. Now, what I'll do in a minute here is I'll throw in some numbers and kind of play around with this. But when I look at the picture that's drawn here, they connected the center to XY and we called that the radius. But then they drew in these other sides here. What are they creating here? What kind of triangle? A right triangle. What have we used in the past with right triangles if I knew how much some of the sides were to solve for a missing side? Pythagorean theorem. We've used a squared plus b squared equals c squared time and time again. Okay, so I'm going to kind of think about that when I'm coming down here. So I'm just going to write this out. A squared plus b squared equals c squared. I'm going to use Pythagorean's theorem to kind of help me along with figuring out how this equation of a circle got created. Now, I don't have any numbers, but like I said, I'm going to just put in some pretend numbers here. I'm just going to grab a couple things that I think make sense based on our picture, and we're going to go forward with them and see what happens. So for my graph here, for x, y, I'm going to call this point 8, 10. And I'm going to call the center HK. I'm going to say that that's at 3, 4. Just based on the picture, I feel like those would maybe be appropriate numbers for how far over to the left and up these points seem to be going, okay? But someone could argue that this point's at like 9, 10 if they really wanted to. So it doesn't really matter for right now. What matters is just I'm trying to show you how we get to our equation of a circle. If I wanted to figure out how long these straight edges were, so like these dashed lines that they drew in to create the right triangle, would we be able to figure out how long this side is? Or how long this side is using these two numbers? Anyone have an idea how we would maybe do that? If we think about the bottom of the triangle, is this along our x-axis or our y-axis? X. So do I have my x coordinates here that would maybe help me figure out how long that is? 5. How'd you get to 5?
I went from 3 to 8.
3 to 8. Because it was at 3. If I just follow like the distance that it went to the right there, it was at 3, it went to 8. That's a difference of 5. So I'm just going to write that here. And let's call this side our A. We'll say A is 5. What would this side be? We'll call it B, because I'm thinking about Pythagorean theorem. What would this be? A number?
6.
6. Because what are you doing? Going up from 4 to 10. Could you also just do a quick subtraction? 10 minus 4, 8 minus 3 gives me my 6 and my 5. Okay, so I could also think about subtracting here. If I were to just like plug these in now to find radius, I could. So back over here, I could put in for A, 5 squared. In for B, I could put 6 squared. And in for C, I could put R squared. Okay, and then I could go through the motions, I could square the numbers, I could add, I could square root, all that stuff, okay? I don't really care to do that right now. I don't really care how much the radius is, but I could do that if I wanted to. What I want to think about, though, is how could I write this as a general idea, something that I could use for any situation? Because like I said, I just threw in random numbers up here. It could be anything, though. This circle could be anywhere on the coordinate plane. This one is primarily, I would say, in quadrant 1, because the majority of it is here. But I could move it over to quadrant 2 or 3 and 4. So let's think about letters now. When we got the 5 and the 6, we said that we were thinking about distance between two numbers. And I said maybe think about subtraction. When I found the 5, I was doing 8 minus the 3. Letters-wise, that would look like this. X minus H. So I'm just going to write that on the bottom here. X minus H. What would we write to represent how we got the 6? What minus what? Y minus K. So if I start plugging these into my Pythagorean's theorem, so thinking about this equation again, it's going to give me my standard form of my circle, which I'm actually just going to write down here. So maybe I'll just draw an arrow going this way. Instead of A squared, because I said my A was 5, I'm going to replace A with this quantity, X minus H, because this could represent any circle that I have out there. So I'm going to write X minus H in parentheses because it is going to be squared, and I want the whole thing squared. So using the same thing for B, we said B could be replaced by this Y minus K. So plus, instead of B squared, we're going to write Y minus K squared. And then I would still have equals R squared, because that's still this third side. This right here is the equation of your circle. And I hope now you can kind of see how it related to that Pythagorean theorem, A squared plus B squared equals C squared. When we look at this, there's two main things that we should be able to pull. The center, which I said at the very beginning of class, is your HK. So these numbers here, H and K, those will be filled in with numbers in your equations. The X and the Y will not. The X and the Y will stay X and Y, because those could represent other points that are inside the circle somewhere. HK will represent your center point, and R will represent your radius. Now notice that this will say R squared here, so we'll have to think about that when we're actually pulling the radius. Now, a couple of questions that we have underneath here. I'm not going to do a Desmos here today. I'm just going to have us think about this. Which variable, so thinking about this equation here, which variable do you think is going to affect the size of the circle? And maybe think, do you imagine when you're looking at a circle, do you think the center point is going to affect the size, or will the radius affect the size? Anyone have a guess?
Well, can the center point be moved or does it stay?
The center can be moved.
So could it be the center point? That would change it.
That would change this, like how big or small it is?
Yeah.
Okay, maybe. Could the radius though? What's the radius measuring?
From center point to edge.
Center to the edge, okay? So there's actually two questions down here. One of them, and let's just look at them together. One of them says which variable or variables control the size of the circle, and the other one says which one controls the position of the circle. So I think we have to just decide right now. Do we think the center is going to control the size or the position of the circle? And do we think the radius is going to control the size or the position? I agree with what you said, Anna, that the center can move, okay? I don't necessarily know if that's going to affect how big or small it is. I think the radius plays more into how big or small it's going to be. But with the center being able to move, I think that's going to help us know it's going to affect where it could be positioned at. Because I could take my 3, 4 there, I could make them both negative, and that would change where the circle is at on my graph. But the radius could still be the same and still make it the same size. Or I could increase or decrease the radius and make it bigger or smaller. So down here, I'm just going to write out that the radius is going to control the size. Because if you have a bigger radius, so a bigger R, you're going to have a bigger circle. And the same could be said opposite. If you have a smaller R, you have a smaller circle. Okay? The variable that controls where the circle is going to be at is the center. And I want to talk a little bit more about that HK. So from my equation up here, I said to you the X and the Y back up here are never going to be filled in with numbers. Just the H and the K will. Maybe you notice right now that they both have minus signs. There will come a time where all of a sudden the equation you're working with doesn't have a minus sign anymore. It changes to a plus sign. So we need to talk about how do we deal with that. The H is going to represent your X. So that's going to make it move either left or right. And let's talk about how you tell when it does which. So I'm going to write out two cases. You could have it say X plus 2, or you could have it say X minus 2. So in your equation from above, it could say X minus 2 squared or X plus 2 squared. If it's plus 2, this means it's going to move left. If it's minus 2, that means it's going to go right. Sometimes that can be a little hard for us to wrap our minds around because it feels a little bit backwards. When we go left, we're going towards like the negative numbers on the number line. If you're just on a regular number line and you're going to the left, it's usually going to smaller numbers, to the negatives. So when they put a plus sign there, it feels a little bit backwards to our brains because we're so used to thinking going to the left means negative. But if they put in a negative number, if up here in my equation they had written X minus a negative 3, what happens in math anytime we have a minus minus? Becomes positive. Keep, change, change. You've maybe heard that before. You keep the first sign, you change the next two. If you have a minus minus, it always becomes plus. So when a plus sign shows up in our equation, it's because they threw in a negative. If it stays negative, like the second one looks like it does, X minus 2, that means that they put in a positive number. So it does make sense, actually, if you think about how those numbers are working. It just feels a little bit backwards to us. Now, the K, that will affect whether it goes up or down. So that's going to play into your Y. So you could have Y plus 2, Y minus 2. And again, it's backwards. Plus 2 means it's going to move down. Minus 2 is going to mean it goes up. Again, that's all because of the numbers that they're putting in. If they put in a negative number, which does mean it went down, it changes to a plus sign. If they put in a positive, it stays with the minus. So what we're going to do now is start working with the equation of the circle. The first, I would say, couple sets of problems are going to be us really being able to practice identifying the center and the radius. And we'll do a little bit of graphing here with these first couple. So let's take a look at the first one, letter A. I want to graph the circle. In order to do this, I need two things, center and I need my radius. If I have those two things, I can graph it. To find my center, I always look at the numbers inside of the parentheses. And I always tell students it's always the opposite of what it appears. So right now it says x minus 3. You're going to take a positive 3 out. And this one says plus 2. Y plus 2, you're going to take a negative 2 out. So your center is going to be at 3, negative 2. Now the radius, that comes from the very end, the 16. But remember the 16, that's representing our r squared. So what do I need to do to the 16 to just get r? Square root it. So what is the square root of 16? 4. So let's talk about how we would graph this. How I like to graph my circles is I do my center point first. So I'm going to go 3, negative 2, like that. And then I like to use my radius to just kind of give me an idea of where the circle is going to go. So from the center point, I'm going to go up, down, left, and right 4 to kind of represent the radius in all those directions. And then you just connect those. Now, when you're connecting them, make sure that you're trying to make it a circle. We don't want stick straight lines that go from point to point. We're not making squares here today. We're making circles. So it's okay if they're a little lumpy, okay? If they're not like a true circle, it's hard to do that for the first time, so it might take some practice. Okay, you guys go ahead and try letter B. Identify your center, your radius, and try to graph it. So what's your center for B? Good, negative 4, 2. Very good. Make sure you pull opposite signs. And what's the radius? 3. Very good. Make sure you square root the 9. Okay, it also, if I'm giving you a problem where you have to graph a circle, the circle should fit on your graph. So if I had my radius of just 9 here, it wouldn't fit. And so that would maybe hopefully be like a little bit of a red flag of like you did something wrong. Okay, so I'm going to go ahead and graph this now. I'm going to go negative 4, 2, and I'm going to go up 3, left 3, down 3, and right 3. There's your circle. All right, any questions on graphing circles? No. Okay, so we're going to continue to do some of the same stuff on the back side here, but we're just not going to graph anymore. Okay, for these next two, I just want us to grab the center and grab the radius. So if you look at the first one, what would you guys say your center is? 8, 0. Why 0? Yeah, there's no K attached to the Y. There has to be something in parentheses here. Okay, and there isn't. So it's just a 0. Shh. If you're not going to pay attention, that's fine, but you're not going to talk over me. What's the radius? 5. Because you got to square root the 25. Okay, what about the second one? What's your center? And then how would we find the radius for this one? We'd have to square root 14. Now, I'm probably going to want the decimal for that because if I had to graph it, I don't know how to graph the square root of 14. So I'd probably want to do this. I have 3.7 down for that. So if you're dealing with a number that's not nice to square root, you will need to figure out what the decimal is, and I would just round it to the nearest 10. Okay, you guys go ahead and try to do 3. There's 4 of them here. I'm just going to put a little star by D. Be careful with that one. Make sure you fix something before you try to grab anything there. Okay, let's start going through these. For 3A, what'd you say the center was? And the radius? 4. Very good. For B? 0, -8. Radius is 2. Okay, how about for C? 2, 1. Radius? 10. Great. Okay, those should all have been fairly straightforward. You're just pulling opposite signs for your center, square rooting that last number. Now, I put a star by D. Anyone know why? There are no parentheses around the y and the -5. Okay, they do not go together. This 5 actually is on the wrong side. This 5 needs to be over here. Okay, it does not go with the y squared. If it doesn't have parentheses, then it doesn't belong with the center. That's actually telling us something about the radius. This is not considered right now to be in the standard form. I would need to do a little bit of rewriting. All that means is I just need to move that 5 over to the other side, and I would do that by adding it. So it would actually look like this. Now you should be able to pull what you need. What's the center? 1, 0, and what would be the radius? Square root of 5, which is about, anyone know? I got about 2.2 when I did it. So I would just make sure when you're doing these on your own that you're square rooting that number. Use a calculator if you need to. All right, the last thing I'm going to talk about is kind of the opposite of what we were doing. They're giving us the center and the radius, and they want us to just write the equation of the circle. So if we look at the first one, what happens when we have zeros for our center? Yeah, it's just like x squared or y squared. This time they both have zeros, so they're both just going to say x squared plus y squared. And then equals what?
16.
Good, 16. Make sure that you're squaring the radius this time. We're going the opposite way. Don't square root the 4 and write 2, but you have to square it now and get 16. Okay, what about for B? They're giving us actual numbers now for the center.
X parentheses x minus 3 squared plus parentheses y minus 7 squared.
Very good. Equals.
100.
Very good. Remember, when you're plugging them in, it always has a minus sign. When you look at letter C, though, what's going to happen? There's going to be one that changes to a plus sign because we're putting in a negative number. So if I were to start writing this, what would it look like? X plus 3 squared plus y minus 5 squared equals...
36.
Ooh. What?
What?
They tricked us, right? They gave us the diameter of 6, so the radius is actually 3, so it's 9, because 3 squared would be 9. So really pay attention to that. They're throwing in some of those things to make sure that you're catching it. Okay, last one here. What does it look like? Equals. What happens when we square a square root? The signs cancel, the square root and the square cancels out, and what pops out? The number. So it's just going to be equal to 11. Good. Okay. I'm going to hand out the worksheet for you guys today, and you have the rest of the period to be working on that.